let's determine if the series is convergent or divergent. The idea is to use the integral test here. In part A, we have the sum from n equals 1 to infinity of e to the negative n. So if we're going to use the integral test, we first have to find f of x. What is f of x going to be? If a sub n is e to the negative n, what's f of x?
E to the negative n.
Except the input has to match this right here. So e to the negative x. Okay, before you try to apply the integral test, before you try to apply the integral test, you have to decide whether or not f of x satisfies the hypotheses of the integral test. Positive, continuous, decreasing, PCD. Is the exponential function, whether it's e to the negative x or e to the x, is that positive?
Yeah.
It's going to be positive. E to the negative x is the same as 1 over e to the x. And we know e to the x, we know that if the base is positive, the exponential function will always be positive. In other words, its graph will always lie above the x-axis. So e to the x is always positive. 1 over e to the x is positive. So that's good. Number 1, just show that the function f of x is bigger than 0. That's positive. Is it continuous?
Yes.
Yeah, just make this statement. Since y equals e to the x is continuous, that's a known result from Calculus 1, so we can just use it. So is its reciprocal, which is 1 over e to the x. On the relevant interval is all that matters. So it's on the interval from 1 to infinity. This guy happens to be continuous everywhere for all real numbers. But all we need is that it's continuous on the relevant interval. So in the future, you might have, in future problems, you might have a function that's not continuous at, say, -1. But that doesn't matter if it's not in the interval that you're referring to. Yeah.
Should it be y equals e to the negative x?
No, I meant, that's f of x. I meant to call this y because I'm on purpose referring to the exponential function without the negative. Okay? And then over here, I then mention that its reciprocal function, which is e to the negative x, so that's f of x, right?
Oh, so you're
I'm saying if y equals e to the x is continuous on 1 to infinity, so is its reciprocal, 1 over e to the x. You're not going to have a problem with the reciprocal function being continuous on the relevant domain if the original function is continuous, or in this case, if this function is continuous. So no, I did that on purpose. Positive, continuous, decreasing. F of x equals e to the negative x. If you're not sure how to show that it's decreasing, what can you resort to?
Graph.
Graph it. The derivative. We looked at something like that yesterday, right? So if f of x is equal to e to the negative x, what's f prime of x? Negative e to the negative x. Is that going to be positive or negative on the interval from 1 to infinity?
Negative.
It's less. It's negative for all reals, right? So that's less than 0 for all reals, but you only need it to be less than 0 for 1 to infinity. So you're golden there. And if the derivative is less than 0, what does that mean about its parent function?
So it's decreasing.
Thus, f of x decreases for all reals, and certainly on the relevant interval then. Okay, so you have to show that it's positive, continuous, and decreasing. Once you've done that, you can apply the integral test. Does that make sense? So, we then want to look at the integral from 1 to infinity of e to the negative x dx. So here's good review for the test, right? This is an improper integral. This is something you need to know how to do on the test tomorrow. All right, so if it's tough to find the antiderivative, then you might want to do that separately, but here it's not tough. We're going to do it all in line. How do you rewrite this thing in terms of what does it mean to have that infinity in the upper limit? Yeah, it's really a limit idea. The limit as b goes to infinity of the integral from 1 to b e to the negative x dx. And I'll work downward now. So evaluate the integral, apply the fundamental theorem, and then at the very last you evaluate the limit, don't you? The very last step. So keep the limit, don't drop the limit notation, keep it around. Okay, what's the integral? What's the antiderivative for e to the negative x? Negative e to the negative x. I pulled the negative out in front of the evaluation brackets. You don't have to do that. Either way is fine. All right, so apply the fundamental theorem of calculus. Don't forget the limit symbolism in the next step. Limit b goes to infinity. Okay, so what do you get here? E to the negative b minus e to the negative 1, which is 1 over e. Everybody see that? Okay, what's the limit of e to the negative b as b goes to infinity?
0.
It's 0, right? That 0 is a horizontal asymptote for that. If you don't believe that, look at a graph. But yeah, that's well known. So we're saying this guy goes to 0. Don't forget that there is a negative out front, though. So what is the value of this limit? It's 1 over e. Everybody believe that? Okay, now we should make a statement about the integral and then go back to the series. So what about the integral? So the integral e to the negative x dx converges. It converges to 1 over e. Does the series converge to 1 over e?
No.
No. So I'll say this, and thus the series, the sum from n equals 1 to infinity of e to the negative n converges. By the integral test, we can shorten that to IT, I guess, IT, integral test. Now, let's emphasize, we don't know what the sum converges to. I'll put that in brackets. We don't know. Whoops. We don't know what the series converges to. I can almost guarantee you it won't be the same thing as the related integral. We don't know what the series converges to. We just know that it converges. That's the best we can do. Okay?